So I have a nice big blank board here to write on. So we just talked about paths and circuits and what they were. Now we're going to talk about Hamilton paths and Hamilton circuits. So a Hamilton, always have the wrong color pen to begin with. Hamilton, let's talk about paths first. Hamilton path. A path in a connected graph that visits every vertex once and only once. Did I forget anything? Let's see. You can actually look in your book to see how they have the definition written. This is just to point out that this definition is important. Hamilton path, a path in a connected graph that visits every vertex once and only once. Okay, so for an example, I like this example that I made up that I've been using in all of my videos today. Don't know why. I guess it's just a little bit different. So, Hamilton path. A path in a connected graph that visits every vertex once and only once. Well, you have to know what a path is, but we already talked about that. It's when you start at a vertex and travel on distinct edges, distinct adjacent edges. Okay, so in other words, a path would be from A to B, B to C. That's a path of length 2. Well, that's a path of length 2, but in this graph, that would not be a Hamilton path because you have to visit every vertex once and only once. So let's see if there's actually a Hamilton path in this graph. Not every graph will have a Hamilton path, but I believe that there is one in this graph. Okay, so if I start at A, I could go to B, then I could go to C, then I could go to D, then I could go to E, then I could go to F. That is a Hamilton path in this graph. We visited every vertex once and only once, and that's definitely a path. We traveled along distinct adjacent edges. Notice that you don't have to travel on every edge in the graph. This edge here never will travel on. That's not one of the requirements. The requirements are you have to visit every vertex once and only once. So this graph does have a Hamilton path. Let's see if I can make another one. Draw another graph, maybe a more complicated one. And without knowing whether or not it has one to begin with. Let's see. I'm just making this up because I want to show you something. I want you to see my struggle. I don't know if this has a Hamilton path or not. Now that I look at it, I see that it does. Kind of wanted to make one that might not have one, but it's all right. So I could start here and go from there to there, and here to here, here, and down here, over here. And that would be a Hamilton path. I visited every vertex once. I traveled along distinct adjacent edges, and remember, in a path you finish at a different vertex from which you started. So that's a good Hamilton path. Okay. Now we're going to talk about what a Hamilton circuit is, which you can guess. It has a similar definition to Hamilton path. Matter of fact, I don't have to erase this whole thing. I can just erase a couple words in it before I lose my voice again. You can guess what I'm erasing, right? Wherever I see the word path, I'm going to change it to circuit. And we're going to go back to my favorite graph that I just made up today. We saw before in a previous video that this graph does have a circuit. You could start at B, go to C, then go to D, then E, then D. That is a circuit, but obviously that's not a Hamilton circuit because you have to visit every vertex once and only once. So if we did that circuit, we would have never visited A and F. It turns out that this graph does not have a Hamilton circuit because there's no way, if we start, let's say out here, there's no way to visit every vertex once and only once. So once we get out here, remember a circuit has to end where it started. So once we get out here, the only way to get back up here would be to go back here. But you're not allowed to do that. You can only visit every vertex once and only once. So this graph does not have a Hamilton circuit. There's plenty of graphs that don't have Hamilton circuits. Let me draw an example of one that does. That would be easy to do. All they have to do, if I wanted to make a graph that did have a Hamilton circuit, is to draw an edge there. Okay. Now this graph does have a Hamilton circuit. You can just go from A to B, B to C, C to D, D to E, E to F, then F to A. So every vertex has been visited once and only once. Now I know you might say, well, we've been to A twice. Well, the place you start and finish at, that's considered just visiting it once. So we didn't visit that twice. We started there, and then we finished there, but that's just considered visiting every vertex once and only once. So that's a Hamilton circuit. It's just a circuit in a connected graph that visits every vertex once and only once. Now, in the next video, we're going to talk about complete graphs, because moving on for the rest of the chapter, the most important type of graph is a connected graph that's called a complete graph. That's what we're going to use in traveling salesperson problems.